Hello, in this video, we are going to see the election algorithms in distributed cloud systems. In cloud computing, there are multiple distributed nodes working together. Among these nodes, one node needs to be chosen as a coordinator to handle the certain tasks, such as the load distribution, synchronization, resource allocation, or the failure recovery. Then, what is the purpose of election algorithm? First purpose is to ensure the fault tolerance. If a coordinator node fails, another node must be elected automatically. Next purpose is to maintain the consistency. That means only one node should act as a leader at a time. There should not be more than one node. And the third purpose is to support the scalability. That means in a large scale distributed systems, leader selection must be efficient. There are two basic types of the election algorithm. First one is the bully algorithm, in which always the higher ID process become the leader. And second one is the ring algorithm. Here, all the processes arranged in a ring, and the leader chosen through the message passing through the ring. Let's see the bully algorithm in detail. The bully algorithm is the leader election algorithm, where processes with the higher ID always become the coordinator. How it works? Suppose there are multiple processes in a system. When the coordinator fails, the process starts an election. It sends message to the all higher ID processes. If no higher ID process respond, then the initiator process will become the leader. If a higher ID process responds, then that higher ID process continues that election further. Bully algorithm guarantees the strongest process as a leader. It is a simple algorithm but has high message complexity, that is order of n square. Let's see one example of the bully algorithm. Suppose there are 5 processes in a system indicating with their IDs. Here, higher ID is equal to higher priority. Therefore, process number 5 is the coordinator now because it has the higher priority. Suppose that coordinator node fails. Third process tries to contact with the coordinator but no reply from the coordinator because it is the inactive. So process number 3 get to know that our coordinator is dead. So he initiates the election. He sends that election message to the higher IDs. That is the process number 4 and process number 5. But fifth process is the already dead, so no reply get from the fifth process. But process number 4 replies to the 3. Hey, I am alive. So you don't have the right to become the leader. So that election process further carried out by the process number 4. It sent the election message to the higher IDs. But fifth is already dead, so no reply from the fifth ID. Process number 4 thinks that no one is bigger than me. I am the winner. So process number 4 become the new coordinator and it sent that message to the all the processes in the system that I am the king. Suppose the inactive process, that is the process number 5, become activate again. Then that process enters into the system and it initiates that election algorithm again. But there is no higher ID process than the 5. So 5 thinks that no one is bigger than me. Then fifth process is become the coordinator again and it sends that message to all the processes. So let's see the ring algorithm in details. Ring algorithm is a type of a leader election algorithm where processes are arranged in the logical ring and the election message are passed until the higher ID process is chosen as the leader. How it works? A process detects that the coordinator fails and it starts an election. It sends an election message to its next neighbor in the ring. Each process adds its own ID and forwards that message to its next neighbor. When the message returns to the start process, then it selects the highest ID as a new leader and that new leader or winner message is circulated to announce the new leader. Let's see one example of the ring algorithm. Suppose there are 6 processes in a system. Here also higher ID is equal to higher priority. So process number 6 is now coordinator. Suppose the sixth process become the inactive. Process number 4 tries to contact with the coordinator but no reply from the coordinator. So process number 4 gets to know that our coordinator is dead now. So that fourth process initiates the election. It sends election message to its next neighbor, that is node number 1, along with its own ID. One gets message from the 4 and it sends that message to its next neighbor, that is node number 3, along with its own ID. So it's add its own ID in the message and it's send this message to the node number 3. 3 also did the same. It add its own ID and send that message to the next node, that is the fifth node. Because the sixth node is the dead node, therefore sixth node is out of the ring now. Fifth also did the same thing. It's add its own ID into the message and it sent that message to the its next node, that is node number 3, node number 2. Second node also did the same process. It's add its own ID and it's that message sent to this next node, that is node number 4. Fourth node is the initiator of this algorithm. So fourth node has the IDs of the all processes in the ring. Fourth thinks that fifth is the biggest number. So fifth number is the new coordinator. So fourth node circulates that message through the entire ring. That is the fifth is coordinator, fifth is coordinator, fifth is coordinator, fifth is coordinator. So fifth process becomes the new coordinator and sixth is still inactive. Let's see quick difference between these two processes. In Bully algorithm, always the highest ID process become the leader. In ring election algorithm, highest ID process chosen after circulating the message. Here message sent to the all higher ID processes. No lower ID process get the election message. But in a ring algorithm, the message passed through the circular ring. That means lower ID, lower priority process also get that message. Here the complexity is order of n square, but in the ring the complexity is order of n. So it is more efficient in smaller systems. If the higher ID rejoins the system, they need to reclaim the leadership. But in ring algorithm, if that higher ID process rejoining the system, they need act as a normal member until any new election occurs. Bully algorithm is the faster, but ring algorithm is the slower because each process gets the message, it's add its own ID and pass to the next node. That message must circulate through the entire ring. At last, in the modern cloud systems, more advanced consensus algorithms like Raft and Paxos are used. But Bully algorithm and the ring algorithm are the fundamental concepts of the understanding of distributed systems. Thank you.